We're covering logarithms. So let's begin with an introduction to logarithms. So you already know how to solve the following equation. 2 to the power x is equal to 8. What you'll try and do is get them to a common base. So we have 2x on the left-hand side is equal to, and 8 can be expressed as 2 to the power 3. So that's 2 to the power 3. And since the bases are the same, we can now equate the exponents, and that just simply means that x is equal to 3. So easy stuff, nothing mind-blowing. But what happens when we don't have common bases, when we can't get our numbers to a common base? For example, consider 2 to the power x is equal to 9. So using the previous logic, let's write them in terms of base and exponent. We'll have 2 to the power x is equal to 3 squared. Now, surely you can see that these are not common bases, so we cannot say that x is equal to 2. Besides, if we say x is equal to 2, 2 to the power 2 is 4, and we know that 4 is not equal to 9. So we can't use that logic. So what do? Instead, we use logarithms and our calculator. So we're going to use logarithms and our calculator to solve this, and it will be equal to the log of 2, the log of 9 to the base 2. And that's how we'll solve it. We'll insert it on our calculator and we will get an answer. So notice that the x variable exponent is always equal to the logarithm. In the above example, I had x is equal to log of 9 to the base 2. This is what a logarithm essentially is. It's an exponent. Okay, so the below analogy should help explain logarithms clearly. The first equation here is called exponential form, and then we have logarithmic form. So the number that you have, which is the base, is going to be raised to some exponent, and that's going to give you some output value, the number that you want. Now the exponent is always equal to the logarithm. So the exponent is equal to log of the number that you want, and then at the bottom, the number that you have. Another way of remembering this is take a look at this exponential equation here. The base is 2 and it's raised to the power x. The exponent is always equal to the logarithm, so x is equal to the log of something. Now this 2 is called the base, so we can relate it to the term basement. Okay, basement, base, it's all at the bottom of something. So this 2 is the base here. It's in the basement. You can see how it's a subscript and it's smaller under the word log. So you can think of the 2 as being in the basement, and then the only number remaining is the 9, and that's going to be in brackets. That's the number that you basically want. So that's how you can convert from exponential form, an exponential equation, into a logarithmic form. Okay, just remember that the exponent is equal to the logarithm, and this 2 is the base, so put it in the basement. That's as a subscript to this log, and it's read as the log of 9 to the base 2. So let's do some examples and actually get a feel of how logarithms work. So exercise 1, solve 24 to the power x is equal to 78. So let's do this example. We have 24 to the power x is equal to 78. Let's take this equation, which is currently in exponential form, and let's put it in logarithmic form. So the exponent is always equal to the log. So the exponent is x, and that's equal to the log. Now 24 is the base. It's in the basement, so let's put it in the basement. That's going to be here. Okay, think about it as there's a house here. Oh, that's a weird looking house. There we go. There's a house, there's the basement. Right, so 24 is there, and then the only number that remains is the 78. And then we're going to type this on our calculator, and let's check what answer we get. So we get an answer of 1.37. Let's use 4 decimal places, 1.3709. Okay, so we got the answer. The calculator gave it to us. Now, before we move on, let's actually think about what this is. Okay, what does this 1.3709 mean? This 1.3709 is what I must raise 24 to. So I must say 24 to the power 1.3709. And obviously there's some decimal places that I've cut off by rounding. But I must raise 24 to this number 1.3709 in order to obtain 78. So put that in on your calculator and check that this quantity here gives you 78, or basically something close to 78, because remember we did round this off. And that's what a logarithm enables you to do. All right, that's exercise 1. Okay, let's go for exercise 2. So again, solve for x. So let's take this exponential equation and write it in logarithmic form. So we're going to have the exponent is always equal to the log. So the exponent is x, and that's equal to the log. What's the base? 90. So let's put it in the basement. There we go, 90 in the basement. And then the number that remains is 34. So x is equal to the log of 34 to the base 90. Type this in on your calculator, and let's round off to 2 decimal places. This time you're going to get 0.78. Now it's not enough to just get the answer. We need to understand what this answer means. 0.78, what does it mean? It means I must raise 90 to the power 0.78. So 90 to the power 0.78. And once I do that, it should give me 34 or something close to 34, because again, I rounded off. So that's what this, again, what logarithms help us to do. So let's get some notation out of the way, and these are basically two special logarithms. We have log of x to the base 10, and because the base 10 is so common in math and in logs, we just write it as log of x. So when you see log of x in some texts, it basically means base 10, right? In most texts, okay, log means base 10. So if you just see a log with no base, you assume it to be base 10 unless otherwise stated. Another notation that is extremely common is ln(x), or some people say ln of x. That is log with base e. So the base is e. And you may not know what e is. So the second special case is called the natural logarithm. And it's weird because natural logarithm, it'll be nl. This is ln. I'm looking at the first letters and acronym. But anyway, it's not English. The base number is e, which is known as Euler's number. So what is Euler's number? It's basically an irrational number similar to pi. You can think of it as the cousin of pi if you want to. And it's equal to 2.71828, and it's got obviously an infinite number of digits going on because it is irrational. So right now it's just a number between 2 and 3 for you. And when we have that as base, so when we have log with base e, we write it as ln. Again, just because it's so common in mathematics. So that's just notation. If you see log x, it means log of x base 10. If you see ln x, it means log of x with base e. Let's move on to some logarithm properties. So there are 5 properties here, and you obviously need to learn them. So the first one is we have log of, and again, notice here I have log. I don't have a base, so I'm saying that it has log base 10. That's what this notation means. But these properties don't apply just to log base 10. They apply to any base. I'm just using log because it's easier notation. It applies to any base where applicable. So log of AB, so it has to be A multiplied by B within the brackets, and this is obviously going to become log of A plus log of B. Note, you cannot do this. Log of A plus B, that becomes log of A plus log of B. Going from this and then simplifying it to that, that is totally incorrect. You cannot do that. What you will have to do is leave this as is. You can't simplify that. A and B have to be multiplied by each other in order for you to separate them like so. Now, if we can transform the multiplication into addition, we should be able to transform the division into subtraction, and that's what we can do. A divided by b, that becomes log of a minus log of b. Again, you cannot separate log of a minus b into log of a minus log of b. This here will remain as is. You can't simplify it. Only if it is a divided by b, then can you simplify it. So that's the first and second property, really easy. Third property, another really useful property. When you have log of a to the power b, and a to the power b is within brackets, you can actually take that exponent b out and place it in front of the logarithm. So it will become b times log of a. Let's go for the fourth one. So if you have log of b to the base a, this can simplify to log of b over log of a. And how do you remember the order? How do you remember that the b, or the number in the bracket, is going to be on top? Well, just look at how it's written. Look at this b, it's basically on the same level as the log. Look at the a, it's a subscript. Okay, so you can basically put a line and see that the b is higher than the a. So when you're doing the division, log of b should be higher than log of a. And notice again, I have log, that implies base 10, but as I've stated, any base can be used. For example, you can use base e, you'll have ln b over ln a. You can use base 3, in that case, you'll have log of b base 3, and then log of a to the base 3 at the bottom. Okay, but the same base has to be used in the numerator and in the denominator. You cannot have maybe base 5 on the top and base 7 at the bottom. It has to be the same base. So let's go to property 5. The next property is that e to the ln x is equal to x. And ln x, it's a bit difficult to see. It's basically log base e, and then we have x. So this base and that base need to be the same. And if they are the same, then your answer is just going to simplify to whatever is in brackets. Similarly, this is the general case, a base b to the power log of x with base b as well. So the bases are the same. This is just going to simplify to whatever is in brackets, and that is going to be x. Okay, and let's think about why this fifth property makes sense, because you may be memorizing it and you may not be understanding it. So let's write it out. We have base b, and the exponent is this thing here. This entire logarithm is the exponent. What I'm going to do is I'm going to replace this with k. So I'm going to take out that and let it equal to k. So now it's b to the power k is equal to x. And let's just remember what k is. K is log of x with base b. That's what we replaced. Now let's put this equation in exponential form. In logarithmic form. So the exponent is always equal to the log. So what we're going to have is k is equal to, what's your base? Your base here is b. So let's put it in the basement, and then the number that you have is x. Okay, so this is it in logarithmic form. And now we're just going to replace k with what we had. So k is equal to log of x base to the base b, and it's equal to the right-hand side of that equation here. So the two sides, the left-hand side and the right-hand side, are equal. So that is why this property here holds true. All right, let's apply these properties in some examples. All right, exercise 1, simplify log of. Just note that there is a bracket around this fraction. Okay, so simplify that using the log properties. Okay, so this one is going to be log of, we can see we have division. So it's x minus 1 divided by x plus 2. So it's going to be log of x minus 1 to the base 21 minus division becomes subtraction. And then we're going to have log of x plus 2 to the base 21. That was the base, we do not touch that. Now question, are we going to simplify this further and say it's log of, and we have the base 21, x, and then it will be log of 1. Okay, are we going to simplify this to this? No, we aren't. Okay, this would have to be x divided by 1, basically. but it's x minus 1. We cannot simplify it if it's subtraction. Only division becomes subtraction. Likewise, multiplication within the argument of that log would become addition. So here is your final answer. All right, that's exercise 1. Okay, let's try exercise 2. So we see we have the natural logarithm or ln of x squared plus 90 multiplied by x minus 1. So this can be simplified. We have multiplication to ln of x squared plus 90 plus ln of x minus 1. Okay, so that's your final answer. All right, exercise 3. So take some time with this one because it is a little bit tricky in terms of your signs. Okay, let's do exercise 3. So you can see we have division clearly. So it's going to become log of, and you can see we're using base 10 here, so I'm just going to write log of x plus 3, and then it's going to be minus log of, and what's the denominator? It's going to be x minus 3 into y minus 4. There we go. Now what I'm going to do is I'm going to do something extremely important. I'm going to put a bracket around this second log term. And it's going to become log of x plus 3, that remains unchanged, minus, and now in the argument of this log we have multiplication. So we're going to split that up using the log laws and it will become addition. So it will become log of x minus 3 plus log of y minus 4, close the square bracket. Now you can see why I use square brackets, because I must distribute this minus sign to this log and then to that log. So your answer, your final answer will become log of x plus 3 minus log of x minus 3 minus log of y minus 4. So that is your final answer for exercise 3.